Assalamu alaikum warahmatullahi wabarakatuh. The next part, go to 19.5, right? This section, before we move to that section, it will discuss about the equation that I introduced you in the last video, which is Ohm's law, right? The equation for the Ohm's law. This is the potential difference. This is the current electricity. This we are calling as the resistance, right? The resistance. Now, to understand what is resistance, right? We can make a small idea on a circuit, right? Take a circuit, the battery. Here, the current is going to flow. I am saying the potential difference that has been made by this battery is 3 volt. I am saying, right? Now I need 1 ampere of current, right? I need to move 1 ampere of current through this circuit. Okay, I have 3 volt of battery. If I want to really get this 1 ampere, that if you go to this equation, the V is equal to IR, the V, the potential difference is 3 volt, right, which is going to be equal to the I is 1 ampere, and the R value is going to be 3, right? Normally, the resistance is given in the unit, we are calling this as ohm, right? Which to respect that is ohm, right? Which is symbolized like this, right? That is ohm. Right? Then the 3 ohm is going to be the resistance. The value of the resistance is going to be 3 ohm, right? Therefore, the meaning of this is, in a circuit where the 3 volt of potential difference has been maintained, if you want to get 1 ampere of the electricity, the current, then you have to maintain 3 ohm of resistance in the circuit. We'll see what is resistance, right? We have to maintain 3 ohm of resistance in this circuit. Now, if you want 3 amperes of current, right, you have to maintain the resistance in 1 ohm, right? Then for the resistance mean, right, that is the controller to get the electric current more or less, right? If you need more current, less resistance should be maintained. If you need less current, 1 ampere, then 3 ohm more resistance should be maintained. In other words, we can say, if resistance gets high, the current is going to get low. The current flow is going to get low, right? Therefore, the resistance mean, right, a factor or physical nature or the physical quantity which is related to, which is depend on, right, the current electricity, or the current electricity is depend on this. There is a relationship, right? Now, we'll try to understand what is resistance, right? What is resistance? Now we'll take a structure of a conductor. Now you know there will be atoms, right? There will be free electrons, right? Now, if you are making an electromotive force in this direction, then the electrons are going to move in this direction, right? Keep this in your mind. Electron has a mass, which means it has a size. The rest of the part of the atom also has a mass, right? Which means it's going to occupy a place. It has a shape, right? It's going to occupy a place, right? The rest of the place are going to be vacuum, right? Because of the particle nature of this electron, this always going to move through the gap between the atoms, right? It doesn't going to move through the atom. It's going to go in the gap between the atoms. right, by the electromotive force. Now, when it moves, right, normally by the concentration of these atoms, right, by the arrangement of the atoms, right, the difficultness is going to felt by this electron, right? Some sort of difficultness is going to be felt, right? That difficultness is known as resistance, right? How much of difficultness has been felt? Okay, more difficultness mean the electron is struggling to move, right? If there are more resistance, right, more difficultness, in other words more resistance, then if it is struggle to move, then the current is going to get reduced, because the movement of the electron is going to be very slow if the resistance are high. Okay, this resistance is depend on three factors of this conductor. The first factor, if you think about the length of the conductor, I am going to get a conductor with a more length, right, and I am going to consider this electron to move, right? Now this electron is going to feel its difficultness in all the places, right, and it's going to feel for a long distance. Therefore, by increasing the length of the conductor, right, the electron feeling more difficultness, which means more resistance is going to be built up by the conductor. Then by increasing the size of the conductor, length of the conductor, right, then the resistance is going to get increased. Therefore, the first factor, right, of the conductor, right, which is influencing on the resistance is length of the conductor. By increasing the length, you can increase the resistance. That is the first factor. The second factor, which is making an influence on the resistance is the cross area of this. Now, if you increase the cross area, right? If you increase the cross area, right? The gap between the atoms are going to be increased. Not the gap is going to be increased, right? We can find more gaps, right? More gaps to move the electron. Then electron easily finds some gaps and it's going to move very quickly, right? It's trying to move quickly, right? Therefore, by increasing the cross area, we can decrease the resistance, the difficultness, right? Therefore, the resistance is dependent on the second thing, which is known as cross area. If you increase the cross area, resistance, the difficultness is going to decrease, right? Then if you take the resistance is directly proportional to the length. If you increase the length, resistance is going to increase. But the resistance is inversely proportional to the cross area. Why? If you increase the cross area, this fraction is going to decrease. By this, the resistance is going to decrease. Right? It's inversely proportional. This is directly proportional. This is inversely proportional. In an equation, right? In a proportionality, we can show this as like this. The R is depend on L and the A in this manner. If you increase the A, R is going to decrease. If you increase the L, R is going to increase. Okay? Right. Now, to equate this, you have to multiply by a constant. It's going to be like this. This constant is known as, right, coefficient. Sorry. What? resistivity. Right? The K constant is known as resistivity. Normally resistivity is given in terms of rho. Right? Therefore, the resistance of a conductor, right, can be measured using this equation, which is R is equal to rho L over A. Right? If a piece of conductor is given to you, right, the length of the conductor and the cross area of the conductor and the resistivity is given there, then you can give a value for the resistance. Right? Now this resistivity is depend on the material itself. Right? The material of the conductor. Right? For an example, if you take one material, the arrangement of the atoms are going to be like this. In another material, the arrangement is going to be get different. Right? Because of the different arrangement of the materials, the particles of the materials, right, the difficultness is going to get reduced. Right? Then the resistivity means that is depend on the arrangement of the atoms or the material, the nature of the material, right? The composition of the material, right? This is the equation that we are using to find the resistance. Now, you know what is resistance. The resistance depend on three things. One is the length of the conductor. Second is the cross area of the conductor. The third part is the resistivity or the material composition of the conductor, right? There is a activity is given in page number 153, right? That activity is to find, but is to illustrate, to compare these three factors, how it is going to related with the resistance, right? That is given there, but you can see that thin, thick, and everything is there. All right, using these equations and activity, reading this activity, you can understand little more about this. Okay, that is the 19.5. Inshallah, we'll see the 19.6 in the next video.